Hello guys, I'm Eric. Welcome to this Audiocenter video. So in this video, I'll be discussing about one of the line array project that we installed in early 2020, which in a school hall. So I can show you some of the pictures and some of the videos just to have you give you some idea on the system. So as you can see from here, I have posted the pictures and the video on our Facebook page, Audiocenter Malaysia, and also in our distributor page, AV Electronics Marketing. So you can subscribe to our Facebook and our YouTube at AV Electronics Marketing, and also follow our Audiocenter Malaysia Facebook page here, in here. So let's have some picture of this project. So we have a full range as a stage monitor, and we have an array system here. And then this is what we are doing, the sound system tuning of the hall. You can see the two array is here. A closer view, you can see a subwoofer is hanging on top, only one unit and 4 units of the array. So the side view. And then this is during the installation time, hanging the array up. So another picture of the installation. So the man in the white shirt is our staff, Lai. He's the one who helped on the installation and do the smart tuning for this hall. So a closer view on the flybar of the subwoofer and the array. And this guy is Hoksun, our sales. He's the one who proposed to this hall and managed to confirm the sales for this project. So if you want some expertise in line array system for hall, you can contact him. I will share the contact below. Hoksun, Lim Hoksun. And then this is one of the simulation that we done. So in this video today, I will be sharing you some of the ease focus simulation that we can do for you. So that is all. So let me read the description. Full Audiocenter system installed in SMK Chung Hua Kota Kemuning. Initially, their system was very bad due to incorrect system being installed. So the echo and the reverberation was so bad, and there's not even a word spoken can be listened, can be heard. So this is what the headmaster told us, that the original system that they are using is cannot hear. The student cannot hear what even a word from what spoken by the headmaster. So that is the issue they are having initially. So our reseller installer, we work together, so we have a solution for the venue. So the bad thing is that they are not going to spend any money on the acoustic treatment. So we only can design a sound system to minimize, and the budget given by them is also quite limited. So that is quite a challenge. So we are not able to fully eliminate the reverb and the echo, but we can, with some clever design, we can minimize the echo and the reverb. So we are not going for distributed system. We are going for line array, because distributed system at this hall is performing worse, because the original system is a distributed system, and they have to push the volume higher so they can reach to further, and that is the one causing the echo issue. So let me further explain why the distributed system perform worse in this hall. So in distributed system, we have so many speakers installed around the hall, and to ensure that it can cover the whole hall, because it's a big hall, we need to up the volume, and this volume will have more reflection. Imagine one speaker system, they have their own reflection from the wall, ceiling, and floor as well. So of course, with proper speaker and proper positioning, we can reduce the reflection from the ceiling, because if we aim at the audience. But a little bit also, we have some of them coming from this maybe from the wall or ceiling. So that's for one speaker. Imagine you have 6 or 8 speakers installed all around the hall. So when you push the volume up, so you have the echo and reverb from the 8 system. So you have times 8 times. So what we are planning is to have a single source from the front aiming at the mid and the back. So this is a line array system that really shoot to this location, mid and the further part. And this volume is quite high. So definitely there will be a reverb as well and reflection from the wall and the floor as well. But because of this high SPL, the reverberation, what we can say that it may be not so noticeable because the high SPL of this narrow aiming. And the front field speaker helps to make sure the volume at the front part is high enough so that the reflection from the back that come back, it become not so noticeable. So that is the aim that we are planning to do with this system for this hall. So what we propose is to have an array to shoot at the mid distance and the further distance, and then we have a front field to cover just the front part. So the front field, we are going to delay properly to the system so we don't have any two sound. So to make sure the transition from the near field to the mid field is as smooth as possible. So this is what we are going to do here. So basically we are installing 8 units of KLA 28. So that is a double 8-inch line array. So 4 per side, and then we have one subwoofer per side. So for this case, the subwoofer is not so important because this is normally for the speech. I mean, majority of the usage is for speech, and occasionally they maybe have some performance that need some bass, but they doesn't need a very heavy bass. So we doesn't propose any double 18. Just a single 18 subwoofer hanging on top will be enough. And then we have a front field speaker, the 12-inch, just to fill the gap of the missing part at the front, and stage mount for the stage monitor purpose. And the processor we are using is the Pro 26DX from IBA. Mixer is Behringer X32, and the stage we have a S16 snake box there. Then we have a look on the video just to share to you all. So this is Mr. Lai doing the sound tuning to make sure the smoothness from the nearest to the mid and to the furthest is smoothest. So what do I mean by smoothest is the frequency response between all these spots is almost the same, doesn't vary much. So let's play the video. It's doing the ping noise, so beware, suddenly there's a loud noise. So what Mr. Lai is doing is doing some setting on the digital speaker management, and then all this will send to the power amp for the balancing between the array. And from here you can see actually we have a few spots indicated by the red chairs. So we have maybe near field, mid field, and further field, and the mic is putting between different spots, so we can measure the frequency response at different spots. So before we do all this measurement, we already done a simulation based on this venue. So now I'm going to show you on that simulation. Okay, for the simulation part, we are using the software called Focus 3. So you can download this for free. I can share the link below. and we can use the what do you call it, GLL file of the array. GLL file is a characteristic of that array to put into this simulation software, so we can simulate the audio dispersion, the coverage of the line array, and then we can see how each frequencies of the array is covering the area. So what we have here now, okay, just roughly to explain, we have a top view here. Okay, this is a top view from the top to the bottom, and then we have a side view here. Okay, I already have put two array here, left and right. From the top you can see, and then this is a side view. You can see the array is here. Okay, you can see. Okay, basically I just have to make sure I put the correct dimension of the venue there, and then I need to decide at what height I need to mount the array. So that will be depends on the venue as well, whether the height is suitable or not suitable. But of course, there's a certain limitation on the height. We cannot hang too high. So that is a compromise between the venue and the best height location. So for this example of this venue, we have a depth of 34 meter. Okay, that is from the stage to the back. Okay, and then we have the width, I mean from the left to right of the hall is about 29.65 meter. So how do I get that? I just go to the site, use the distance meter to measure, laser meter to measure, then you get this. And then from the height, so I need to determine what is the best location that I can hang the system. So for this example, we are hanging at 7.5 meter. So you can have a X, Y, Z. So 7.5 meter. My array is hanging on 7.5 meter. So because this system is limited in budget, so we only can go for 4 top and 1 sub per side. So normally this scale of venue, I will propose 6 top to have a better coverage, because 2 you can aim at the furthest away, 2 at the middle, and then 2 for the near field. So because of the budget concern, so we need to work with the budget. So in the end, we end up in 4 array per site. Sub is 1 enough for this case. So to compensate of this lack of cabinet, so I'm using 2 unit, the cheaper cabinet front field speaker, put in the middle, so to compensate back the lacking of the array hanging on top. So basically, how I'm going to do that is I'm using the array, the 4 unit, this 4 unit, to aim further. So I doesn't aim to near. As you can see from here, okay, so my top cabinet KRA28 is aiming at around about 33.76 meter. You can see from the bottom left, okay, you can see the X equal to 33.76 meter. So that cabinet, the top cabinet, is aiming at that location. And then we go to this second cabinet. So in the bottom left, the X is 25.96 meter. So that cabinet, we are aiming at that distance. And the third cabinet, is it correct? Yes, correct. Is aiming at 18.2 meter. And the last cabinet, number 4, we are aiming at 12.01 meter. Okay, so this is how we aim. So 12 meter onwards. So below 12 meter, there's no cabinet covering that. So all this sound is coming from off axis, the speaker, because the speaker is aiming there, but we can still listen. So it's similar like your speaker is facing to your audience, but the performer behind the speaker still can hear, but that is not a direct sound. So maybe that is from the reflection from the wall, from the ceiling, and maybe because of the other echo reverb. So that will be not a very good audio quality. So there will be sound there as well, but it's not the best. As you can see now, we confirm that we are aiming 12 meter onwards. So for below, there's nothing. So that's why we have this 2 unit of the TS12, Audiocenter TS12, 12-inch full-range speaker put on the lying mode to cover the near distance. I mean, between 0 meter to 12 meter. That is to compensate back the lacking of the coverage. Okay, and we can have a look with this software each of the frequency coverage. So we can start from 20 kilohertz down to the sub bass. Okay, this is what you can get from 20 kilohertz, quite even. And here there's an indicator, 80 dB in red color, all the way to 30 dB in blue. Okay, we can go down to 16 kilohertz. You can see that it's actually the variation. I mean, from the front is about 90 plus, to the back is about yellow, about maybe 70 plus. So this is the drop. And then for 12.5 hertz, 12.5 kilohertz. So we started to have a quite even sound coverage from back to front, which is 90 plus, to yellow is about 70 plus. Okay, we go down some more. So you're getting more red at the back. That is about 90 plus to 80 plus. 80 plus. Then we can go to 8 kilohertz. So you can see it started to get more even now. And then we have 6.3 kilohertz. So quite even for this venue. 5 kilohertz. This is a 4 kilohertz. So you can notice with 4 kilohertz, the front part started to reduce a bit. You can see from the side view. So they have this hole. You can see hole. That is because of this not a direct sound. Okay. If you go further, 3K, 3.15K. So you can start to notice at the side view, the beam is starting to become more narrow. You see the beam. And those who not in the speaker coverage, they start to have this hole. What we call it? The drop in SPL. We call it hole. No, now. We go down some more. 2.5 kilohertz, 2 kilohertz, 1.6, 1.2 kilohertz, 1 kilohertz, 800 kilohertz, 800 hertz, 630 hertz, 500, 400, 300 plus. Keep notice this dB bar. The color indicate how strong is the SPL. So go further up, 250, 200, 160, 125, and you can actually start notice lower frequency that I go. So we can see more this hole. So that is because of this cancellation between the left and right. So because of the distance between the two array, the low frequency at different distance, they might have some cancellation is happening. So it will affect more on the low frequencies. So as you can see, if you go lower, the dB will start to decreasing because the sub is getting unable to produce that very low, especially on the 30 hertz, 25 kilohertz, and so on. But this model KLA 118 should be performing quite nice around 40. You see 40, there's about 90 dB. 50, there's about 100 dB. 63 is about 100 dB. So it can perform quite well between, I would say, maybe about 40 hertz onwards, it can produce quite nice low frequency. So back to this front field. So most of the frequency that will cause this issue at the front will be around this 800 hertz, 1 kilohertz, 1.5, 2 kilohertz, 3 kilohertz. So this is the area that we call it a hole. I will call it a hole because this is the shortcoming of every line array system, because you're hanging very on top, quite far away, and then in the middle. So that is the blind spot. That is why we need a front field. And because of our design, the 4 array is aiming at the mid and the far part. So we need this front field to compensate back the near field. And plus, their job to make sure to fill back the gap of 1 kilohertz, 2 kilohertz, 3 kilohertz. So let's have a look again. 1 kilohertz, you can see actually there's a lot of blind spot here at the middle. 1.2, there's a lot of blind spot here, so it's not even. You can see not so even. So it's starting from, I think it's about, what is this distance? So we can see from the bottom left, the x is 8.22 meter. So starting from 8.2 meter onwards, we got a quite even coverage. But below that, you see there's a spot here. So there's a cancellation, destruction wave, and then 1.6. So similar issue, we have these parts. So this is 2 kilohertz. Also, we have some cancellation. So this is worse. It's about starting from 12.54 meter away. So that is where we started our bottom array. The coverage started there. And we have 2.5. So roughly about below 12 meter as well. And not so even coverage. And then 3.1 kilohertz. So it's about below 11 meter, and 4 kilohertz. So it's not so even below 11 meter. So starting from 5 kilohertz, so we started to getting more even coverage even at the front part. So this is what I mean from around 1 kilohertz to 4 kilohertz. So we need to add this front field to smooth it out, and also to make sure we can fill the gap due to the location of these two arrays at a very high left and very high right. So basically, okay, this is how we're going to design this array system in this school hall. So by using 8 units of array here, and then we have front field here, and we are measuring the far part. So that's it for the sharing of this project. So there's few more good projects in 2020 for Audiocenter. So stay tuned. I think Andy will have come up with one video about project in a mosque, masjid, coming soon. And then we have another 2 arrays coming soon as well. So in 2020. So hopefully we can have enough material, video or picture or so we can make more this sharing video in our social media and YouTube in the future. So I will see you in next video. Thank you very much and bye bye.